study of probability. The next topic is probability distributions. To study the probability distributions, first we have to understand the concept of random variable. What is random variable? Random variable is a function associated with a sample space of a random experiment, and this function transforms the results of an experiment into real numbers. So in simple language, the random variable is made up of all possible mutually exclusive and exhaustive outcomes of an experiment in the form of numbers. In the probability distribution, the first part is random variable. Now the second part is probability. With each and every possible outcome, a probability is always associated. And when we arrange the entire data of an experiment, all mutually exclusive and exhaustive outcomes, together with its probability, the presentation is known as probability distribution. This is the example of, say, discrete random variable or discrete probability distribution. What do we mean by discrete? The random variable takes finite values, or say countable infinite values. Only single number at particular point we are interested. If random variable x takes value x1, the probability is so and so. Only x1, the value x1 is considered. Similarly, next x2, we are not interested in any value between x1 and x2 or x1 and x2 and x3 and so on. So only the values at a particular point are considered. Then the random variable is known as discrete random variable. The other type of random variable is continuous random variable. Normally we are habituated to see it in the form of class intervals. What is continuous random variable? Continuous random variable means there can be infinite number of values in the distribution, but simply from the lowest value of the data to the highest value of the data, all in between values are part of distribution or part of variable. Then the random variable is considered as continuous random variable. So the basic difference between these two is we are interested in a particular point value, then the random variable is known as discrete random variable. And when we are interested in all possible integer as well as fractional, all infinite number of values between the lowest data value and the highest data value, then the random variable is known to be continuous random variable. So far as the study is concerned, we are going to study first the part is discrete probability distribution. That means now we are interested in discrete random variable only for next 2 to 3 topics. The first topic will be study of mathematical expectation. That means calculation of mean, standard deviation, variance and coefficient of variation on the basis of the probability distribution. But the question is how to arrive at the probability. Number 2, binomial probability distribution, then Poisson probability distribution. Yes, all these are, one is hypergeometric probability distribution. All these are examples of discrete probability distributions. And in continuous probability distributions, the main 3 topics are uniform probability distribution, normal distribution and exponential distribution. But first we will go for normal and exponential only. Before that we will study mathematical expectation, etc. in case of discrete probability distribution. Now the point is how to calculate or how to find the expected value or mathematical expectation of any probability distribution. Our first topic is discrete probability distributions, and in discrete probability distribution again our first topic is mathematical expectation. So you can give a title to your topic, mathematical expectation. First of all, let us take an example in which we are going to cover so many simple and small points. Let us assume that we are going to play a small game in which we are going to prepare 100 chits or 100 tickets. On each and every chit or ticket, we are going to assign only one number from 1 to 5. Each and every ticket will contain only one number out of 1, 2, 3, 4 or 5. So the random variable is made up of numbers 1, 2, 3, 4 or 5. So these are mutually exclusive and exhaustive outcomes of the experiment. Now we are going to prepare say 100 tickets of this type. Now what is the game? Only one ticket will be drawn at random from the 100 tickets which are actually covered. We cannot see the number on it. Only one ticket we are going to draw randomly from the collection of 100 tickets. Now what is the probability that the number on it is 1? So first of all, we have to study the collection of 100 tickets. How many tickets are with number 1 on it? How many are with 2? How many are with 3? How many are with 4? And how many are with 5? Let us believe that there are 10 tickets with number 1, 20 tickets with number 2, 40 tickets with number 3, 20 with 4 and 10 with 5. The summation is 100. At present, this is not probability, this is frequency. Because these are the number of tickets, so these are frequency. For the time being, we are not interested in the probability. Yes. Sigma F, that is 100. Now out of these 100 tickets, we are going to draw only one at random. And what is the probability that there is one on it? So what will happen? To get one, first of all, let us think that how many tickets are there with 1? 10 tickets. These 10 are favorable number of cases to get 1. So total number of favorable cases will be 10C1, because out of 10 tickets, 1 can be drawn in 10C1 ways. Ultimately, we are drawing one ticket out of 100. So total number of possible outcomes will be 100C1, 1 out of 100. And it is nothing 10 by 100 or 0.1. So ultimately, the probability of getting 1 on the randomly selected ticket is 0.1. In the same way, now the probability of getting 2 will be 0.2, probability of getting 3 will be 0.4, probability of getting 4 will be 0.2, and probability of getting 5 will be 0.1, and ultimately the total comes to 1. Now, what is the exact thing? The random variable is made up of all possible mutually exclusive and exhaustive outcomes of the experiment. Each and every outcome has its probability attached to it. The summation of probability must be 1, because these are mutually exclusive and exhaustive cases. So the summation of probability must be 1. Any individual probability will be between 0 and 1. Neither less than 0 nor more than 1, but the summation can never be greater than 1, that we know. So this is the case of discrete probability distribution. Remember, this is actually relative frequency. This probability is nothing but this is relative frequency, individual frequency divided by total frequency. So this is known as frequency approach or relative frequency approach to find the probability. Or many times it also remember empirical approach to calculate the probability, because this is reality. In statistics, this frequency is known as observed frequency. This is reality. There are actually 10 tickets, there are actually 20 tickets. So we have record of the data. On the basis of the record of the data, if we calculate probability, then it is known to be empirical probability. Even for the cases in management, in business, or in any actual organization, on the basis of the record of past or history, we can say construct a frequency distribution, and then very easily on the basis of the frequency distribution we can arrive at the probability distribution. Now the next topic is mathematical expectation or expected value. But for that purpose, first of all, let us try to calculate mean of a frequency distribution. We are going to use this example itself. How can we calculate mean of this distribution? So it is very easy. Multiply f and x, 10, 40, 120, 80 and 50. The summation comes to 300. It is known as sigma FIII or simply sigma fx. And mean is sigma fx divided by sigma f or say n. Yes. So it is 300 divided by 100. So ultimately the mean of this particular probability distribution comes to 3. Mind well, in case of frequency distribution, we have to consider frequencies as weight to the numbers. So never go for sigma xi upon n or sigma x upon n. In case of frequency distribution, the frequencies must be considered as relative weights to the numbers. So, like any weighted mean, remember the weighted mean, sigma wx or sigma xw upon sigma w. That is the formula. In this case, frequency is weight. The same case, it is example of weighted mean. Now, in case of a probability distribution, what will happen? Let us take this case as a probability distribution now. Okay. What are the arithmetical steps in this case? First, we multiplied x and f. So first is multiplication, then addition, and then division. Now, what is this probability? It is f divided by sigma f, simply. So first step was division. Now multiplication. 1 into 0.1, 0.1, 2 into 0.2, 0.4, 4 into 0.4 into 3, 1.2, 4 into 0.2, 0.8, 5 into 0.1, 5, 6. Now summation. Same arithmetical steps are rearranged. First division, f divided by sigma f, then multiplication, and then addition. The result is the same. This is known as mathematical expectation or expected value. So, we can conclude that when we calculate mean of a probability distribution, it is known as mathematical expectation or expected value of the distribution. Yes, if sign is used, this is sigma x into p of x. So, mathematical expectation or expected value the sign is E of x, that is nothing but the sigma x into p of x. Sigma x into p of x. So we can say that E of x equals to sigma x into p of x. So ultimately Expected value or mathematical expectation is mean of the probability distribution. In the same way, we can calculate variance as well as standard deviation. Now, how to calculate variance or standard deviation if we have any probability distribution, or more precisely, if we have any discrete probability distribution? How can we calculate variance? First of all, according to Carl Pearson, what is the variance, or what is the formula of variance? The variance is the mean of the squared values of the deviations taken from mean. Simply, it is mean of x minus x bar whole square. Yes, it is mean of x minus x bar whole square. So now we can say that it is the mean or expected value of x minus x bar whole square, because mean means expected value, we know that. So variance is nothing, it is the expected value of x minus x bar whole square, or of the squared values of the deviations taken from mean or arithmetic mean. But in this case, we require to calculate x minus x bar, or the deviations taken from actual or arithmetic mean. Many times it is not possible to get integer value of the mean. In that type of cases, this process becomes tedious. So we can use other formula. Remember, the other formula of variance, to calculate variance, one formula was sigma x square minus sigma x square, the simplified version is sigma x square divided by n minus sigma x divided by n whole square, or more precisely sigma x square divided by n minus x bar square. Now we know that x bar is nothing, it is expected value. Now what is sigma x square upon n? So this is also mean of x square. So ultimately mean of x square means expected value of x square, e of x square, minus square of expected value. So e of x whole square. Through this formula, we can calculate variance easily, whether it is the case of integer mean or fractional value of mean. And now we know that standard deviation is nothing. It is square root of variance. So ultimately it is square root of e of x square minus e of x whole square. And the last coefficient of variation, popularly known as CV. CV is percentage of standard deviation to mean. Now the question is, how to calculate variance? Like this. We need only one additional column. We need e of x square. That means expected value of x square. Now we know that expected value of x is sigma x into p of x. So logically, expected value of x square must be sigma x square into p of x. We need only one additional column, that is x square into p of x. X square into p of x. Squared value of x only, p of x is not actually the squared value. So ultimately x square into p of x is x into p of x. x into P of x. 1 into 0.1, again 0.1, 2 into 0.4, 0.8, 3 into 1.2, 3.6, 4 into 0.8, 3.2, and 5 into 0.5, 2.5. What will be the summation? It is 10.2. This is sigma x square into P of x. This is E of x, we know that, and now this is E of x square. E of x square. Variance equals to E of x square minus E of x whole square. E of x square comes to 10.2 minus E of x whole square comes to 3 square. That means 10.2 minus 9 or 1.2. This is the variance of our distribution. Now standard deviation, square root of variance, that is square root of 1.2, something less than 1.1. It will be around 1.09, is it? And if we are interested in coefficient of variation, that will be 1.09 divided by 3 into 100. Approximately the third part, it will be around 32% or so. Sorry, more than 33%. 36.33 approximately. So this is how to calculate expected value, variance, standard deviation and CV in case of a discrete probability distribution.